This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
In Chapter 9, we continue with operations management by looking at some of the tools and techniques which are used. First, we look at some elements of process design, how a process is carried out. For example, who does what happens in which department, what is the movement of materials and perhaps information as the, say, production or the delivery of the service proceeds. So it's the people involved, the movement of material, the movement of information, and the process is carried out. And the first thing is to find a way in which the process, whatever it is, can actually be depicted. And the first a tool, if you like, is what's called a process map, sometimes known as a swim lane diagram, for fairly obvious reasons that going across this diagram, it looks like an aerial view of a swimming pool. And each of the lanes, if you like, really different person or different departments. So we have customers, sales, credit and invoicing, production control, copying, feasibility and shipping, and so on here. And the idea is this shows how, in this case, how a sales order is going to be processed. So the customer generates an order, and then it is presumably received here in our sales department. We are going to be passing it on then to the credit control and the invoicing department. They do a credit check. If it's okay, we'll just go along this method here. The credit is okay. Then what we can do is we can begin the production of the goods down here, the production control, or at least find out if they're in inventory. The invoice will be prepared. If it's in inventory, then what we can do, be going down here, we can go to the warehouse, we can pick the order, we can ship the order and so on, and hopefully eventually we're going to get the payment being received. If it's not in inventory, not in stock, then we have to schedule production, we have to package and assembly the goods here, and then it can be put into its box, its delivery package, and shipped again, and so on. Meanwhile, along here, the invoice has been prepared, and provided we're confident that the order has been sent to the customer, then we can send the invoice as well. So that's just sets out who does what ways. In some cases, it's predominantly information which is being moved. So here, there's basically a process where information is being transferred. Has a credit check been passed or not? Down here, we have a lot of physical movement of goods and so on. And the idea is that certainly if a new employee were to join, they can quickly understand what the process is. But it also allows people to kind of analyze what's going on here to see, in particular, are there any steps that could maybe be removed or combined? Are there any elements of simplification? Are there any ways in which maybe the whole process could be made more logical and more efficient? So, process maps are used for both manufacturing and service industries to document the way operations should or are carried out, and to analyze the processes, so documentation and analysis, to see if they could be improved. Now, the improvements which might be possible are of three types, or at least the changes. First, we have automation. And automation is essentially doing, by machine, really the same steps that traditionally had been done manually. But you're not really changing very much more. So an example of automation would be producing wages and salaries by computer rather than a great room full of people working out the wages and salaries for all the employees in the factory. Another example of automation we see every day really in supermarkets. When you buy goods, scanned at the checkout, automatically the inventory is updated, and automatically purchase orders can be sent out to suppliers when the goods have fallen down to a sufficiently low level to trigger the ordering of replacement goods. But essentially that's always what was done anyway manually. Look at the goods going down and send out an order when they're at a low level. Rationalization sometimes is described as the removal of bottlenecks, some sort of restriction in what's making things efficient. And if I pick up that example again of the supermarket, again the kind of traditional way, even when automated, was a supermarket would monitor its inventory and send out orders to the suppliers as it needed them. You might think that's fine, but think of it from a supplier's point of view. Orders come at you rather out of the blue. You don't really know when to expect an order from a particular customer. And as soon as an order comes, immediately you have to see, can I dispatch those goods? Do I have to make the goods and then dispatch them and so on? There are certain inefficiencies in that. And the example of automation and rationalization we have is that we change things around a little bit. We say to the supplier, we say, you monitor your goods at the supermarket. Essentially, it's using an extranet. You have the supplier who is given access to the stock records at their customer, the supermarket. You can be watching your goods going down in the supermarket, and therefore you can anticipate when an order or when replenishment is needed. And what we want you to do, Mr. Supplier, is to send those goods when you think we need them. Don't wait on an order from us. You are responsible for making sure we always have the goods. And you can see this is going to be a much more logical and better way of replenishing goods, because the supplier can gear up, if you like, and start manufacturing well in advance. He can even put the goods on a lorry and get it halfway up the motorway, ready, if you like, just to unload at the customers when they need them. Business process re-engineering is a very radical change to the way things are done. Some people say that just-in-time inventory, where you don't keep any inventory, is essentially a business process re-engineering approach, so radically different from having inventory. Some people say it's just rationalization. There is no hard distinction between these two. It's really a matter of degree. And the story which is often told in terms of business process re-engineering was Ford Motor Company in America. And they had a huge manufacturing plant in Detroit, Michigan. And this was really at a time before there was much computerization. And they had in that factory, they had an accounting department called Accounts Payable, which basically looked after invoices coming from suppliers and the payment of the invoices and so on. And you can imagine in a huge car company, there were an enormous quantity of invoices and so on coming in and had to be processed. And the traditional way of dealing with this was you would get copies of the orders, and you would wait. They'd be filed somewhere, and then when the goods received, you get a kind of copy goods received note, and they would be presumably matched and pinned together, and you would wait, and then you have the invoice coming in from the supplier eventually. And when the invoice came in, you had to make sure that yes, they're invoicing for what was ordered, and we've got the goods, and they're invoicing at the right price, and the invoice is calculated correctly and so on. And then you would maybe credit that to a payables ledger, and then 30 days later you would pay it. And there's an awful lot of kind of just paper shuffling and paper matching going on and reperforming calculations. And at one stage in that department, it said there are about 400 people employed, just in this paper shuffling. Then somebody had the radical idea and says, why do we need invoices? And it said to the suppliers, don't send us invoices. We know we've ordered the goods. We know what price we're going to pay for those goods. We know when the goods have come in. And 30 days after the goods come in, we'll pay you. But don't send us an invoice. It just adds work. We don't need it to trigger the payment. And 400 people in accounts payable allegedly went down to about 40. Simply by radically changing the approach to processing invoices. Now, this wouldn't work in every country. In some countries, you require basically invoice for taxation purposes and value-added tax purposes and so on, but it worked fine in Detroit for Ford Motor Company. But a radical rethink. Almost, people sometimes say you start from kind of zero-based. You said, if I could start again, what would be my kind of ideal way of running this business? Where would I put it? How would I organize my departments? How much would I outsource? How much would I keep in-house? And that's what we're going to try and aim for this perfect, basically perfect set of operations. One of the things we need to look at, and one of the techniques we need to look at, is of course we want to supply goods economically. We have to give customers what they want, but we have to do it at a price which enables us to make a profit. And one of the processes we can carry on in doing this is what's called value analysis. And value analysis kind of looks at what we put into the product and says, is there anything really we could cut out of that wouldn't hurt, if you like, customers' perceptions? Could we do it more cheaply, more efficiently, in a way that would still please customers? And it said there are two elements of this value analysis to be looking for. One is use values. Let's say we're making cars, okay? So one is use value, okay? And when you go and you buy a car, one of the things you look at is the capacity, the cc, the number of litres in the engine and so on. One of the things you look at is going to be kind of 2-door or 4-door. One of the other things you might be interested in is going to be air conditioning and so on. These are all very much to do with the use you get from the car. But then there is esteem value. And esteem value is almost your perception of quality, style, how good the car is and so on, quite divorced from esteem value. So let's say the car company wasn't just any old car company, but it was Rolls-Royce. Rolls-Royce is looking around for ways in which it could save a bit of money. And Rolls-Royce cars have, I believe, the seats and so on are made of very nice soft leather. And Rolls-Royce looks at this and says, right, seats, they will support people just as well if we were to change the nice soft leather into textile or even into plastic. Now, in many ways, this is not going to damage or hurt the use value. The seats could be just as comfortable with a textile covering as it could be with a leather covering, but of course it's going to hurt the esteem value. People perceive an element of luxury with leather seats that they don't perceive with textile seats. And if Rolls-Royce were to try to save money by moving towards textile seats, then it would be, in a way, reducing the value perceived by customers. People either wouldn't buy at all or they wouldn't be prepared to pay enough. And the small amount you save in replacing the fabric on the seats is probably going to be way outweighed by the huge amount of revenue you lose because you have damaged that product. What we need to do is to see, of course, what customers want or need. And market research, we're looking at marketing in a later chapter, But market research is very much seeing what customers want or need or value and so on and there. Then what we must do, if we're thinking of designing a new product, is saying, well, which of these products and services that customers want are we actually capable of delivering? Just because a customer wants something doesn't mean we are able to provide that. It may not be profitable. There may be regulatory difficulties in doing it. We may not have the skills to do that. So out of the 4 things that customers might want, we end up maybe with 2 things that we will be actually capable of doing. And then what we do is we think about designing it. And we have to keep an eye on what our customers want. We have to keep an eye on its function, its style, and style. If you think of Apple computers, there's a lot of esteem value there because they look fantastic and so on there. So we have to make sure they do what people want. They have the right stylistic type of qualities about them. And we have to keep an eye on the manufacturing cost. There is no point in what's called over-engineering, where we spend far more than is actually necessary in getting the kind of perfect product that will last for 50 years. Often people maybe don't want that. We should test this on people, and then if we think that is right, we would normally then probably go for what's called test marketing, where you take maybe a small section of the country which is representative, and you try selling your product or delivering your service to this specific town and so on. See whether or not the people in that town embrace the product enthusiastically, because there's no point in trying for national, international launches and maybe making a fool of yourself, an expensive fool of yourself, until you try as far as possible to make sure this product is definitely going to be a success. It's increasingly important to be pretty quick in going from developing new products. Technology changes quickly. We have competitors snapping at our heels, always launching new products and so on. Whereas it used to be that maybe a company would launch a product and that it would be its only product for maybe 3 years, now many companies have to keep relaunching new models, new products and so on several times a year. Because if they're not perceived to do that, then their products are thought to be old-fashioned. And of course, launching a new product gives you a new opportunity to advertise yourself and so on. So it's important to be quick, as I say, really because of technology changing and because of competition. Big drivers, big changes in the environment in which companies operate. Things move much faster nowadays than they used to. We have to get down the time between the concept of the design and bringing it to the market and so on, so that we can keep this stream of products going online. Something else we have to do when thinking about operations management is forecasting. We need forecasting maybe to place orders, to recruit people, to train people. We need forecasting maybe to decide how many lorries we need if we're doing our own distribution and so on. So here we have ordering materials, recruitment, production, scheduling work and so on there. We want to know in advance, if we can, what volume of goods we have to be dealing with, really. And the forecasting that we have to undertake are of 2 sorts. The first one, and the easier one, is forecasting future demand for existing products and services. Because at least for existing products and services, we have some evidence of what the last period's demand was going to be. Of course, it could go up and down, but at least we have our starting point to adjust it up and down. More difficult is forecasting the demand for new products, radically new product being brought to market with maybe no idea, is it going to sell 1,000 a week or 1,000 a day and so on. And of course, we're having to make really quite expensive decisions if we get them wrong. If we build a factory that's far too big, or we contract with manufacturers to supply more of the goods that are ever going to be developed. Now, insofar as demand for existing products can be predicted or forecast, the two main tools are as follows: linear regression and time series analysis. Now, basically what linear regression does, it has two variables. So basically what we could say for example, is that we can say that maybe kind of January, February, March, April, what we do is we look at maybe the demand, 1,000, 1,200, 1,300, 1,400 and so on. So we're seeing here a pretty nice sort of progression. Every month seems to add another 100 onto our demand. And if we were to do what's called linear regression as a statistical technique on this, this will come up with a very, very good fit. This would be essentially enabling to predict that by the time we get to May and June and July and August, we're going to be going up to 1,400, 1,500, 1,600, 1,700 and so on. Of course, even with this beautiful regular pattern of what's happening here, there is no guarantee it's going to keep like that. I mean, many products, they go through a kind of launch phase, they become very, very popular, and they go down again. This is what's called a product life cycle. And as I say, past performance is no guarantee of what future performance is going to be and so on. But as I say, at least it gives you a hint, perhaps, of what's going on. So linear regression is a useful form of forecast. You have to be a little bit careful about some of it. If you've only got 4 bits of evidence, as we have here for January, February, March, April, then it's maybe not statistically very sound. If you saw the sales going up 100 each month for the last 12 months, then you maybe feel you're on a bit of safer ground, although the downfall could obviously happen in the next month. The second thing you need to watch about it just a little bit is that even though there may be an association between two variables, it doesn't mean that there is a causal effect between them here. So if this was our sales here, we have our advertising here, and we were to do something like this. So it's kind of saying every time you increase your advertising by about 10, then we're increasing roughly our sales by 100. It's very tempting to conclude that increasing advertising causes the sales to increase. In fact, what might be happening in here is just coincidence. It could be that simply the economy is improving over these several months. As the economy improves, the sales are improving anyway, and it's nothing to do with the advertising at all. Time series analysis looks at, we have potentially a time series analysis here. It looks how variables move with respect to time. And sales is quite a good one to be looking at, but it's slightly more sophisticated than linear regression, because what linear regression does, it only gives you a straight line. It only says as every month progresses here, the sales are going to go up a constant amount. It is linear, and will give you the best straight line it can through any set of variables. Time series analysis is slightly more sophisticated. It recognizes that quite a lot of, let's say, product sales goes through a kind of seasonal variation in particular. That if you were selling ice creams, then sales in summer are going to be higher than sales in winter in general. If you're selling holidays, then there's obviously a seasonality about the holidays and so on. None of that can be captured by linear regression, but time series analysis gives us a chance of looking at that. And what it recognizes, and what in particular time series analysis is capable of trying to give us information about, are the trend and the seasonal variations. A seasonal variation is any variation of less than a year. Okay, so it could be variations within a week. So if you were a shop on a high street, if you look at sales on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, you will see they go up. You know, they'll be higher on the Saturday, if you like, than they are on the Monday. So, and that is a seasonal variation. It's a repetitive pattern of a cycle of less than a year. It can be in terms of the the weather seasons, summer, autumn, winter, spring, and so on as well. There will be what are called cyclical variations. This is a cycle length of more than a year. By and large, we don't worry about those. They're quite hard to pick up. The sort of things that might give rise to these is the economies of the world tend to go through a very long kind of period of a cycle, typically maybe 12 years of good times and then maybe kind of 12 years of bad times and so on. Usually happens too slow to be affecting very much of what our predictions are going to be. And then of course there are random variations. If you're a clothing manufacturer and the weather turns out in spring to be much colder than you would have been expecting, then of course the sales of your summer clothes aren't going to go as well as you would have predicted, but there's not much you can do about that. You can't capture in advance random variations. But the trend and the seasonal variations we should be able to have a chance with. So here is really what we mean by the trend and the seasonal variations. This curved line here represents the actual sales. And I think you can see by looking at it that there is a rising trend. Although it goes up and down, lying under that there is an idea it's going up in general. And this kind of dotted line that's been put through here, this is what's called the trend. The underlying increase, or indeed it could be a decrease, but here it's an increase in sales or costs or whatever. And then superimposed on that we have this fairly regular seasonal variation. So again, if it's sales of clothes, each of these high points here can maybe be summer. And maybe each of the low points here are winter. And the way you use this, if you're going to be predicting forecasting what the future is going to be here, you project the trend up like this. And of course, you're not guaranteed it's going to keep increasing. It could fall away. The economy could fall to bits, and suddenly all of your sales rapidly fall off. But it's the best you can do, perhaps. And then what you do, you say, well, I want to predict summer, 2 years away. So here's kind of 2 years away, maybe. And we know summer is going to be up a bit, don't we? So we know summer, chaos here. We know summer is going to be up a little bit in there. So that is going to be up there in terms of the trend. Let me just see if I can get my pen back. I think that should be it. We're going to go up like that. And if we're asked to predict what winter is going to be in 2 seasons' time, then we know predict on, and then we subtract a bit of the sales and so on. So in a way, kind of what we're doing, maybe 1 or 2 years, we're predicting that. And this is going to give a more accurate, more detailed forecasting of perhaps what the future is going to be. We're never going to forecast what the future is going to be. It's only forecasting our best guess at what the future is going to be. When it comes to forecasting demand for new products, we're working much more in the dark and so on there. And we have to kind of scratch around for whatever evidence we can get here. So we could be looking at what the popularity of products seem to be that are being sold by our rivals, similar products and so on. We could go out and we could ask people, we say, if we were to sell one of these at a price of $15, would you buy it? And would you find it attractive at that price? Would you find it a useful and desirable product? And we can maybe pick up a little bit of information like that. We can maybe consult experts for their opinions, marketing experts. We can try test markets. I've mentioned those. When you come to launch a product, don't launch it in a whole country. Launch it in one town which is representative, and you can get a huge amount of information about the popularity of that product and when and where it sells well, that you can then use when you expand that product through the whole country or indeed through the whole world. And then there is something called a Delphi technique. This is where experts give their opinion. So they say, well, I think sales are going to be 1,200, one might say, somebody else might say 1,000, somebody else might say 1,100. And then what you do is you feed them back and you say, well, the consensus seems to be that sales are going to be about 1,050. What do you think about that? And they look at that 1,050 and they had in their mind, of course, their old ideas. And they think, well, I predicted 1,200. They'll come out with this answer of 1,050. Do I think 1,200 is too low, or do I want to stick to my guns? Do I want to modify my output as well? And you send it around kind of several cycles until everyone ends up with a figure that they don't want to move any further, that everyone can kind of live with as being a reasonable figure for predicting what the future trends are going to be, where we have very little information coming from similar products. That was looking really at sales. Coming back into the organization, we can look at layout and flow. This is basically how your machines are laid out, where physically really the steps in the production are. And then flow is how materials and documents and information flows maybe from one machine or one department to another. And you need to know really what the four layouts are, the four main patterns are. First of all, a fixed position layout. And in a fixed position layout, the product doesn't move, but people come to it. And essentially this would be like if you're building a house, the plasterers come, the electricians come, the plumbers come and so on, but the house stays where it is. Pretty much if you're building a ship as well, it's not going to move anywhere until it's launched anyway, and then it might go off to be fitted somewhere else. But the people put in the engines, the electrics, the plumbing, and so on. That's fixed position layout. It can maybe be the only method which is available for very large units being produced. Next, you can have a functional or process layout. And in the functional or process layout, can handle various process requirements. Basically, you have fixed machines and you move products around them as needs be. So here you have your drilling machines, here you have your cutting machine, your testing machine, your plating machine, your polishing machine. If one product needs drilling, cutting and polishing, it'll go from here to here to here. If another product just needs drilling and plating, it'll go from here to here and then maybe polished and so on there. If something needs all of them in here, it'll maybe go drilling, cutting, plating, polishing, and then we test it and so on at the end. But essentially the processes are fixed where they are, and you move the products around as needs be between them. They're very flexible, they're fairly robust. If maybe your polishing machine breaks down, then maybe what you can do is you can put lots of people onto cutting and so on. You may be able to get some inventory in there, and then when your polishing machine works again, you can kind of eat into that backlog and so on there. Pretty easy to supervise. You will have a supervisor in the cutting room, a supervisor in the polishing room, and so on there, because you have these dedicated teams. Can be a little bit difficult to manage because if your products are some are going everywhere, some are only going to 2 of the processes, some are going to 3 of the processes. You have to make sure that the products go to the right processes needed for that product. It can also produce some scheduling difficulties as well. Items might suddenly appear in polishing when you didn't expect them because you forgot that they went straight from drilling to polishing. They didn't need cutting, so they come a day earlier than they are expected. It's possible to organize it, but there are just some little difficulties there. Next, we have product layout. And here each product progresses through each process in the same way. Now, it's a bit like the previous example, but we're really setting up a kind of separate production line for each product. So this could be drilling, this could be cutting, this could be polishing, this could be plating, this could be testing. But for that particular product, it's going to go through all 5 of those processes. The second product that we have here, it might miss some of those out. So it might just have kind of some of them in there, and so on. But generally speaking, when we talk about this product layout, we're going to be having not that kind of flexibility, but every single product will always go through every single process. And this is the product layout. It can be linear. It may save time a little bit. You may be able to share some of your workforce. If it's in a U shape, that doesn't maybe make a lot of difference. It can get a high volume going through. It can get it going through very, very efficiently. It can be made to work like clockwork and so on. You could have a skilled person specializing in each of these processes and so on. It is very typical mass manufacturing sort of a layout where you get high volume, low cost, efficient production. It can be a bit dull for the employees there who are always going to be standing at process 2, always treating every product coming through in the same way and so on there. It means that, of course, the amount of skills they have is very low. They get very good at one thing and they repeat that very often, get very efficient at it and so on, but that's not necessarily the best sort of a job. Finally, there is a cell layout, and here we can have machines grouped into a cell which process items that have similar processing requirements, but not necessarily identical process requirements. So here, product 1 perhaps needs cutting, drilling, and polishing. Maybe product 2 maybe only needs drilling and polishing, and so on, like that. So you've got different cells, different parts of the factory really set up for different products being made. Within each cell, it's quite linear. And there are considerable advantages here, good compromise between allowing fast throughputs and maybe high motivation there, because sometimes a particular worker might be moved from, if it's a kind of person who's skilled in cutting, move from making that product to move maybe to making that product, and then maybe in the 3rd week there's maybe another product down here that they can be asked to participate in as well. So, but there can be, of course, as it says, be duplication of machinery. Not all your cutting is going through the one cutting machine. We have another cell with another cutting machine there, and so on. So rather than all cutting going through the one machine, getting very high utilization of that, maybe there's a bit of spare capacity when it comes down to that. But you need to know these differences. Cell layout, the product layout here, and then basically the functional or process layout that we had at the start, and know what's been described to you in maybe a question. Process technology. We're looking here at some new advanced methods of processing of manufacturing here. And you kind of maybe need to know them by their initials here. They're pretty easy to, once you see the initials, they're pretty easy to understand. So computer numerical control, easiest example of computer numerical control is a machine which drills holes. And you can put the product on the machine, and on numerical control, the drill comes in and drills holes at precise locations. Another example is maybe cutting metalwork, for example. You've got your bit of metal there, and under computerized numerical control, in it will come and will cut out, holes and gaps and so on, completely automatically. Robots, we see them, you've probably seen them on videos and television and car manufacturing. They put the bits together, they weld and so on, they move the partially made item from one area to the next and so on, do a bit more processing on it and so on, becoming very, very common in manufacturing. Automated guided vehicles can be used in manufacturing, but also widely used in warehousing. Basically, goods are put onto a little trolley, and the little trolley goes off finding its way around the warehouse, around the factory, kind of knowing where it's going to be going, avoiding other machines that are moving as well, and avoiding people there. And rather than some person having to push this thing along and find out where it has to go, it's automatically guided to its correct destination. Flexible manufacturing systems. One example here of flexible machinery is you have one machine, and what that machine can do, it can bring in maybe a drill, and then it can bring in something to cut, and then it can bring in maybe a punch and so on, then it can maybe polish and so on there. Quickly reset automatically often to perform different tasks. And then route flexibility, where you are making something, it doesn't need the polishing element going on here. It can simply be kind of sent to the next process it needs automatically. So things are automatically routed to provide very flexible manufacturing, leaving out the steps that are not needed. Flexible manufacturing systems should reduce work in progress and inventory, because basically what it allows you to do is to make a unit to order, because it's going to do it very efficiently. It used to be the only efficient way in which you could make goods was really to make large batches of them. You'd set the machine up, and maybe for a week, that machine and its operator would be making the same thing. With flexible manufacturing, you can bring in the drill, the cutting, the polishing thing, the machine changes kind of quickly and automatically. You can really efficiently make one-off products, and therefore you don't need much in inventory. You are getting increased machine utilization. Machine now is really used for many purposes rather than one purpose. So whether it's drilling or cutting, the machine is still being used. Reduces the time and expense and danger of damage that is found in transportation from one machine to another. The product stays there, and in a way different elements of the machine come in and quickly manufacture another process in that product. And because all of this is cut down, the resetting of the machines is shorter, the transportation of the product is shorter, and so on. Scheduling can be more accurate, and the time to manufacture is reduced. Again, cutting costs and allowing a just-in-time sort of operation to be possible. The ability to handle a variety of configurations to make tailor-made products to order, basically reduced labor costs because increasing automation, flexible manufacturing with computer numerical control, these automated trolleys going around the place, greatly reducing the labor costs here and the number of employees who need to be employed looking after machines and simply shifting stuff around the factory. There are potential downsides. It's all very well praising the advantages of modern manufacturing techniques, but you have to realize that these are very sophisticated machines, and there is a very, very high cost involved with these machines. And although here this example which is quoted of the Yamazaki machinery company in Japan, it costed 18 million. It had a big reduction in the number of machines, a big reduction, huge reduction in the number of staff needed, a huge reduction in the area of the factory needed, because of course you've got fewer machines that have to be accommodated and so on there. But the savings was only about 10%. And it didn't give a great kind of return on investment. The return on investment, the big one, was about 10%, which is really quite low. And really, although they were saving on the number of machines, although they were saving in the number of people, the initial cost was so high that it really dented the economic and financial benefit they were getting from this automation. So it sounds fine in theory, but maybe the cheap way to manufacture is just to have a lot of people and pay them not very much money, rather than spend a lot of money on machines and do away with many of your employees. Who knows? Computer integrated manufacture. This is typically what you see and what I've already talked about in manufacturing, maybe cars. The use of computers to control the production process, to make sure the right parts come together at the right place, to actually carry out maybe some welding operations and so on. So here, typically on a website now, you can specify the car you want and its extras and so on, and the computer integrated manufacturing brings these all together in a way that makes your almost unique car for you automatically. So a lot of this is getting away from mass-produced goods where you get a black one, and we're only going to be making this color, and we're not going to be switching to another color for another month, and they're all going to be the same. And now what many companies do is they see the way to profit from saying, well, what color would you like? What engine size would you like? What level of trim and wheels would you like? They're almost tailor-making a lot of the product specially for you. And if they're doing that specially for you, the hope is you'll pay a little bit more for it. And the hope is if we can do it better than our competitor, we're going to win customers from our competitors. I mentioned here additive manufacturing or 3D printing is becoming important. Traditional manufacturing, if you wanted to make many metal components, you started with a block of metal and then you drill a hole through it, or you cut a bit off. That's what's called subtractive manufacturing. And the complexity of the items being produced was somewhat limited and it was a bit wasteful. What additive manufacturing or 3D printing does is it gradually builds a product up. It started off being done in plastic, but now it can be done in metal and other products as well. So you start off with kind of, you make the first layer here. Let's say it's going to be a bit of metal with a hole in it. So they kind of manufacture that, and then the thing moves up again, and you can put another layer on it, and the same hole is there and so on. And you gradually build it up, layer by layer, as though you were printing over and over and over again. And what you're going to end up with after many of these layers here is really a very, a kind of cube shape here. But maybe instead of the holes all being lined up, which you could do by just drilling a hole, what we actually managed to do, because we shift the position of the hole very slightly on each layer we build up, we can maybe produce a really kind of quite complex kind of shape going through it that will be maybe very difficult to produce using conventional manufacturing. And substantial number of parts for aircraft are now being made using this method, because many of the parts being used in aircraft have to be a very complex shape, which are really quite difficult and certainly expensive to manufacture using other methods. Work study. Again, a technique. This is looking how people basically get on with their work. So as it says here, a work study is a system of assessing methods of working so as to achieve maximum output and efficiency. And the types of work study which exist are as follows. Time and motion studies. This is where you watch somebody and you systematically record where they move and how they move products around the place during their job. And it could say, well, you keep going over there to file a document, or you keep going over there to access a computer screen or something of that sort. There's not a lot of time you're spending walking backwards and forwards across the floor, not actually achieving very much. A simple result would be, well, bring that machine closer. Then you don't have to move around the place. Perhaps what you could have is an array of all the machines around you that you need, and you can sit in one place and do it. And that's basically what the sort of thing that time and motion would be looking at. Or it might say to you, every 10 minutes you look at your emails. Maybe it would be better if you looked at your emails at 10 o'clock in the morning and at 4 o'clock in the evening, so that you weren't continually distracted by emails coming in. And that would maybe allow you to use your time more effectively. Method study. What is the best way of doing a job? And this went nearly all the way back. Method study really began, I suppose, about the 1850s. There's a person called Taylor, one of the early management writers, who was one of the first writers who perceived that it's a function of management to try and tell workers how to do their job better, more efficiently. And Taylor did these sort of studies, and one of his famous studies was a variety of employee, then very manual then, called shovelers. And shovelers basically shovel stuff. It could be iron ore, it could be coal, it could be grain, but they had a shovel. You know what a shovel is? A piece of wood with a scoop in the end of it. And he worked out that there was an optimum weight to be lifting. Let's say it's 5 kilograms. So 5 kilograms is the best thing, because if it's going to be much heavier than that, you're going to get tired or getting a bad back. If it's much less than that, you're spending too much time moving the shovel and not enough stuff on it, you're wasting there. So he said maybe 5 kilograms is the optimum shoveling weight to be doing it for a day. And he said, right, but some products, some items you're moving are more dense than others. So maybe if you're moving something which is very dense, if you like iron ore, we'll give you a small shovel. So when you fill it, it's still 5 kilograms. But maybe if you're moving wheat, which is less dense, we'll give you a big shovel, but still when you fill the shovel, it's still got 5 kilograms on it. So here the method study was finding out the best way of doing a job. And then work measurement. If we're forecasting, estimating, scheduling, costing items, and so on here, we need to know how long it takes people to do something. Because usually associated with that, not only is their pay, but how long a machine is going to be occupied in doing something and that worker is using it. So we need to know the reasonable time of a worker working at reproducible efficiency for a qualified worker to carry out a defined task. And we might find it's 6 minutes. And if somebody can take 6 minutes over producing this product, then we know, well, we're producing 10 an hour. And if you're working 8 hours a day, this person should be able to produce 80 of those. So we know it's wage costs, it's labor costs, we know the machine time. We can predict if we get big orders coming in, if our sales are increasing. We can predict how many people maybe we have to recruit to deal with an extra 300 units being ordered in a week. Capacity planning and control is another operations management tool. It's a process of measuring the amount of work that can be completed within a given time. Either because we're constrained by something. It could be the machines, it could be the people, it could be delivering, it could be laying our hands and getting goods coming in, and so on. There's some sort of physical and human resources there. The capacity is the maximum output that can be achieved with a standard set of resources. So the typical number of machines and people available, how many units they can produce for an hour, and how many hours they're going to be working in a week are kind of what's going to determine the overall capacity. What we have to try and do is to say, right, this is suggesting we have maybe a capacity here of, let's say, 1,000 units per week. We're constrained by the number of people, the number of machines, how quickly we can work, how productive we can be, and so on, and how long, many hours a day we can expect people to work. But it all ends up being 1,000 units per week. And we know that our actual demand goes up and down. Okay, so the idea is, how are we going to match the idea of producing 1,000 a week with demand which is sometimes greater than 1,000 a week, and of course sometimes less than 1,000 a week? How am I going to efficiently match our rate of output with the rate of consumption which is needed? And really there are three approaches to doing this here. Basically, you can have a level capacity plan. You say, right, I will buy one machine, one person working 8 hours a day, 5 days a week, and this will allow them to produce 1,000 units a week. And I'm just going to produce 1,000 units a week. And I'm just going to live with that. Okay. And if I get an order in a week for 1,200, I'll say, well, I can only deliver 1,000. You have to get your 200 somewhere else. And you just say it's going to be cheaper for me to maybe turn down some demand than to try to increase my capacity, maybe buy an extra machine, which a lot of the time is never going to be used, and then we're going to have employees idle and so on. So let's say a level capacity plan. There is a chase demand plan, where what you try to do is to adjust your capacity to match demand. So most of the time you're producing 1,000 a week, everything's fine. But then if you get a busy week where there's maybe demand of 1,200, we try and meet that demand in one way or another. Maybe we get people to work overtime to come in on the weekends, shift work. Maybe we buy in work, we subcontract the work and so on. Maybe we rent additional machinery whilst there's very high capacity and so on. So we try to bring our capacity up to meet the demand. And finally, there is matching the demand to managing the demand to match the capacity. We know that if we do nothing, sometimes demand is going to be higher than we can actually meet. So we're going to keep our capacity pretty much level, but we're going to try and manipulate the demand instead of manipulating the capacity. And we see this, for example, in train companies. We know that train companies, a lot of the time, there's no capacity to run more trains. Yet they know that at rush hours, for example, people are going to be standing. It's going to be very uncomfortable. So the way they manage demand is by the price mechanism. In rush hours, or if you want to get to London, for example, for 9 in the morning, the prices are high, and of course this reduces demand. Whereas if you're happy to go in the middle of the day, then the prices are much lower. And they can be a factor of, in the UK, they can be a factor of 10 times lower. So this will encourage people who might have been happy to travel at rush hour but don't need to maybe move the travel period to 2 hours later, where they will get a much lower price, but it is moving demand around the place. Similarly, we have examples in the UK of central heating maintenance engineers. People put their central heating off in the summer, they don't give it a second thought. Come October and November, when it gets cooler, colder, They put it on their central heating system. They say, oh, I should have it serviced, or maybe it's not working. And there's a great demand for central heating engineers in winter. And one way to deal with it, of course, is to pay the guys overtime. But that could be expensive. What we're talking about here is to say maybe we could make an offer to your customers and say, if you have your central heating system serviced in June, you don't need to pay us until December. So what it's doing is trying to get more orders brought forward to the slack period, leaving less work to be done in the period we know is going to be busy. So we're managing the demand. Managing inventory. Managing inventory, we don't want too much inventory, we don't want too little inventory. We've already talked about this a little bit in terms of the pull or the push approach to manufacturing. The push approach to manufacturing would say, well, I think this amount is going to be ordered, and you make for forecast really. The pull manufacturing says, well, I'll wait till I have an order in before I manufacture anything. Now, one's kind of extreme with the other. You can go to extreme just-in-time inventory. But there are actually some quite good reasons maybe for holding inventory. And these are the reasons. To service customers. If what you're doing is promising customers, we will always have stuff in stock, we will always be able to meet with your orders, no matter how unexpected they are, then really as a cost of you pleasing your customers, you have to have inventory. Part of your value chain really. What your customers value is a guarantee that you can supply stock. And part of your, I suppose, outbound logistics is that in your warehouse you will have stock. And this is part of your value added. So one reason you hold inventory is to please your customers, to service the customers. Another reason you might hold inventory is to say, I know I can manufacture very flexibly, but I don't have complete trust in my suppliers. What happens if they're a day late? My people will be a day late in manufacturing and will be a day late in supplying the goods to my customers. It's all very well the suppliers supplying the goods on time, but if they supply bad goods on time, it's as bad as not supplying goods at all. Your suppliers have to supply goods of the right quality on time so you can reliably use them. To make use of bulk discounts. If you buy 1 and 2 at a time from customers, the cost is likely to be high. If you buy 1,000 units at a time, you can normally negotiate a good discount. And it could be that the discount you negotiate makes it worthwhile you holding and investing in inventory. Seasonality of production. If you are producing, let's say, jam, marmalade, something of that sort, then you're pretty well tied to the production of fruit. So in kind of June, July, August, when the fruit is coming, you have to buy the fruit, you have to make the jam, even though that's going to be sold throughout the coming year. You are really locked into dealing with proper seasonality. To make use of favourable prices. Many commodities that you might be buying go up and down in price, and you see it's gone down. Now you say, oh gosh, it's a really good price. I will buy lots and put an inventory because you're expecting the price to go up again. It's a bit of a gamble. The price could go down, and it could go down again, of course. But nevertheless, if you're trying to make use of your, I suppose, prediction of what's going to happen, the market price, then you have to have stock. And certain products, there are technical reasons for holding stock. For example, Scotch whisky or wine. Scotch whisky is typically held for 10 years to mature before it is, certain sorts of it anyway, before it is sold. So actually it's part of the manufacturing process. You are really bound to have huge amounts of stock just to fulfill the process which is going on. How do we order stock? Basically, there are two ways. First of all, there is the reorder level approach. Basically, what you have in the reorder level approach, it's easy to see in kind of, sometimes people use what's called a two-bin method. They have the stock in two bins. So here we have 2 containers full of stock. This one here goes down. So eventually it's going to be empty. And as soon as you have to turn to the second one, that's when you order replacement stock. But essentially what you've done is you've got your reorder level. The stock falls down to this reorder level here, and as soon as it falls to order level, you spark off the order for stock. How much do you order? Well, it depends. It's a playoff between what's called inventory holding stock costs and the cost of reordering. So you could reorder once a year. You could order all the stock you're going to ever need in January. But of course, you're going to have a huge amount of inventory in stock, tying up money and taking up space and so on there. So you're going to have very high inventory holding costs. Or you could say, well, I'll order every day, order a little about every day. There you're hardly ever holding any stock at all, but you're having to order every day and a huge kind of admin stock costs associated with that. What we want is a kind of compromise here. I will order enough stock so that my ordering costs are relatively low. I'm not having to order too frequently, but I will not order so much stock there's an awful lot of money kind of tied up in the inventory. What we're trying to get at there is what's called the economic order quantity, a compromise position of ordering many times a year or ordering too few times a year. And then there is a periodic review approach. Here you don't look at the inventory going down, but basically what you say is I'm going to go around every week. I'm going to look at how much inventory I have every week, and I'm going to bring that back up to what's called a kind of replenishment level. So here we're ordering every week, every month, or something of that sort. That's why it's a periodic review. The same period, the same week we're reviewing it. And you order whatever is necessary to bring you up to the maximum stock. Under the economic order quantity, you order at different periods. You order when the stock goes down to a particular quantity, but you always order the same quantity. And finally, we have just-in-time approach to inventory. Although we've said that there are very good reasons for holding at least some inventory, some companies, of course, attempt to dispense with inventory entirely. Advantages are that the cost of holding inventory are minimized. You're never going to be left with obsolete stock that you've ordered will not be sold. There's much less risk of stock being damaged or becoming rusty or damp or something because it's sitting in a warehouse. You don't need any storage. You don't need people to look after the inventory. Then there's no capital or cash tied up in inventory just kind of sitting there. It's a bit of a kind of a difficult to do perfectly, but people, as we talked about Dell earlier on, can often get very close to it. What you need for it to work are the following. You need very good IT. Because if you're dealing with just-in-time, it means you can't order a lot of product at once. If you order a lot of raw material at once, it implies there's going to be lots of it sitting in a warehouse, which you're going to use slowly. So just-in-time means many small orders. And the only way you can do that efficiently, really, is making use of good IT. You need very, very good cooperation between your suppliers so that they will kind of jump to it when they get an order. They know you can't wait on this. They have to kind of respond pretty immediately, and they have to respond with very good quality stock. So when they deliver the product to you, it's going to work perfectly. Reasonably constant demand. because remember your suppliers have to have the inventory themselves there. And if your demand is radically going up and down like that, it's difficult to know how the suppliers will to manufacture like that. So it has to be reasonably constant, predictable demand. And finally, you need to be physically close. You can't really do just-in-time inventory if your raw materials have to be sent by boat from across the world. That's why Dell gave its suppliers, if you remember, an hour to deliver. And the only way they could deliver goods within an hour was by having their plants physically close to the Dell plant, so that it only took a relatively short transportation time to get to you.